Hello, Earth. Welcome to episode 27 of season 2 of Making Cell, a series of videos where I record myself designing and implementing a programming environment called Cell. If you're just tuning in for the first time, I recommend you check out the project at github.com/autocodenl/cell. The link is going to be in the description. We're going to continue where we left off, which is we implemented the walking put last episode. By walking, I mean that if you're making a call, a put call, or and eventually a get call, but no, sorry, the get already is walking. If you make a put call from within a certain context, the put is going to find the closest name it can find, the closest path it can find. For example, if it will find for a foo, 3 levels deep where you are, and if it doesn't find it, it will try 2 levels deep, if not one, and if not, all the way up. And interestingly enough, it's not just one key. The context path can actually have multiple elements, multiple steps. By the way, I'm starting to call these elements of a path, I'm starting to call them steps. I'll write that down. So yeah, let's see how that goes. Suggested by ChatGPT actually, and I think it's a good idea. Have to get used to it, so it's experimental. Anyway, let's run it. Let's just run it. So yesterday we implemented that, and now we need to do the annotated source code for the changes. So if I just look at the div, actually don't need that, it's very easy. First of all, this one needs to be what? Wait, did I not annotate? Oh, that's cell call. Sorry, I didn't annotate cell call yet. So cell put. Context path. The place from where the call is made. For calls that come from the outside, for example, cell call, this will be an empty array. But what did I explain for context path here? Actually, this is better. Path we're currently sending. The exact same as what cell get receives. Alright, so we have that. This is all the same. We are now going to find a path for which context path for which we get a match on left side. if context path is empty, this context path will also be empty. The interesting case is that for which context path is not empty. This is best explained with an example. Let's say that context path is full. And that left side is bar. If we find a bar inside foo, then the context path will be foo. Therefore, we will update the bar inside foo. Now let's assume that and we know we found one if we get one or more paths there with that prefix. Now let's assume that there is no bar in foo. Then if we get no matching paths inside foo, we will instead fall onto then we'll set bar onto the general data space without a prefix. Instead of falling away the last element of the context path and get this peeling away is done one by one. This is what I refer to as walking up. To implement this walking, we are going to iterate context path length +1 times. The +1 is there in case none of the possible paths no, it's not +1. There's no +1. We will stop the iteration if we find that any prefix of context path gives us so much here. Actually, I can actually do a data stop still work? It works. And it doesn't. Yep. We will stop if but I think this is wrong what I'm doing here, because here what I'm checking is that the context path exists, but what I really need, I need to use the left side as well, right? Let me go back to the examples, sorry, the tests. Yeah, what I need to look is, we need to look for a 1 inside foo. Yeah. So why this example, this test is not covering it? That's what I don't understand. Like, how does it work if it's not taking into account the left side? I guess I will have to do it like this. Yeah. But here I should set bar. Yeah. Okay, that still works. But what if I do this? Sorry, what am I doing? That one. Say I just set foo to something. That's it. Hmm. I am lost. I thought that the reset would work. Yes, the reset is working, so it's Yeah. So if I'm setting bar, it's this one, right? Yeah. Yeah, this one is wrong, but for another reason. Yeah, because I need to fix what I wanted to fix, which is the following. Here, we create a new variable here, context path, which is context path, the one from the outside, from 0 to k, concatenated with the left side. This is my real context path. Okay, I think it works, yeah. Bar 1, sorry, 1, let's make it 1, 1, then foo something. All right, so now okay, that works. Yeah, because he has to use the left side. This is the same thing. Now let's just make it work, right? Work more. Yeah, why doesn't it work up here? Yeah, full one. Is there a full one? Oh yeah, this is completely wrong. My bad. Yeah, let's just do full something else. I want to set bar to 3. Perfect. Yep. Yes, I can see how it peels it out. Nice. This is great. Okay, now it's really working. Perfect. Where were we? Yes, here. This is it. So context path match. We take the context path, remove the last k elements, start at 0 the first time around, and concatenate the left side. This is our context path with suffix. The matches one is the same, I believe, right there. We find any paths that start with this. Now will be like this. Context path with suffix. If we do, if we found a match, this means that this context path plus the left side already exists. We now have a context path we will use. Therefore, we will return it. If we didn't find any context path matches, then we will set it to an empty list. In that case, we'll just put onto the general data space. And the rest is the same, right? Ah, no, then we're gonna do it like this. If it's not undefined, if we found a context path that gets matches, then we'll prepend the left side with it. Otherwise, the left side as is and put, yeah, perfect. The rest is the same. Oh, something I'll reset, the reset function. I'm setting the days. I should run the cell sorter right here. I think so. In case I don't put them in the right order here. And honestly, I should also run the validator, right? No, because no, it's okay. We're gonna leave it as is for now. All right, we really have the walking put, right? We do. So what's next? The dot mode? Yeah. All right. So what are we going to do with the dot mode? The dot mode, basically, you don't walk up. So we could first implement it with the get, right? And yeah, it would be boom. Yeah. Yeah, basically what I need to do here is what do we need to do is implement the dot. It would be bar dot mode would be query path if dot mode query path size 1. So we just basically remove that one, and then this length is the times with the no, this is the times. If not mode is not on, otherwise you do it 1. And it works. Okay, so now, yeah, basically, if you're getting foo in the context of nothing, you get that, yeah. And if you get in the context of inner, you will get 20. Wait, in the case of some, yeah, because I had to add a dot, of course. It should be nothing, exactly. I am getting something else completely. Exactly, it just finds nothing. And if I do this with an empty context, it works. And let's just be a bit more wild here. If I ask for, can I ask for dot? No. Yeah, I guess you can. In a get, you can. In the put, it wouldn't work, or it shouldn't work. Yeah, it works. Perfect. I like this. Honestly, this should be in the same line. Nice. Great. So we added an annotated one here. If the first element of query path is a dot, this has a special meaning. An idea here. Special as non-literal. Just a loose idea there. It means search right here. Don't walk up. In this case, we will set a variable .mode and remove the dot from query path. Nice. However, in .mode, we will just run the loop one time to prevent walking up. Nice, that's it. Okay, same goes for put. So the dot will be in P, right? Yeah. The dot mode thing can be the exact same thing. Yep. Will still work because I didn't use any dots. And the difference is that you would not do any of this. You would just return true. And basically context path match would always be context here. Okay. I'll be right back. Alright, I'm back. So where were we? Yes, we're doing this. we're dotting the put. And I didn't write the tests, I believe, right? For this, no, put with dot now. I wonder if I can really I think I can take some of this. So if I put this there's no query, it will be just a input, right? If I don't pass any context, I'm expecting an OK, and then when I get these ones are gone. Okay, what did I break here? Wow, did I already do the dotting? No, I didn't. What I need to do is, if there's not dot mode, do all this. Still works. If I do a context of something else, what am I getting here? Okay, that's wrong, right? Don't get this at all. It would be like this, yeah. I need to take the context path. Yeah, Okay, there is working, I think. I'm setting the inner foot to 20. And I'm expecting something else to be 20. Yeah. Let's do it with the context of inner. Yep. Okay, this is working. And then I did a put an arbitrary dip. Yeah, that's it. We will survival. Actually, we don't even need the dot mode variable already. We can do if left side yeah. In this case, we will set left side to be the context path plus left side, but removing the dot at the beginning of left side. This dot mode removes the walking up pattern, which is the default behavior. Wait, where am I? Oh my god, I was doing the wrong thing. Oh, that was annoying. I shouldn't have assumed this. I guess I can do the same thing here. No, because I need a dot mode variable. So let's just put it here. That's it. That's the moment that I have the context. All right, so as we'd get, if first element, first step of left side is dot, will be in dot mode, which is a mode that prevents, says we want to set things in the context we have instead of looking up. In this case, we just set left. I had it already written. Otherwise, we're going to find it's all the same except that it's nested. Yep. And I forgot this brace, I believe, yeah. Oh, no, I didn't forget it. It wasn't there before. Okay, now we're good. By now, left side has the absolute path where we want to set the value. All right, it's done. We have a working put with tests and annotated source code. Oh, it's pretty cool that it's so little code, right? Yeah. All right. So now what do we do? Yeah, so in this episode, now we have all of this. So now we do references. Dot mode for get input. That's good. They're both done. So now I need to do reference. So let's just define what we want here. Do you have it? Do you have an example somewhere with what I want to do? No. No. We can start with a simple reference here. Yeah. Yeah. I'm reading this stuff. Use the whole thing as a value. Yeah, who runs the expansions? Yeah. So we're gonna keep this one open. This one we're gonna copy for when we need it afterwards. And then so let's just do something like a simple reference. What would be it? Let's say we have a foo bar, and then something is going to be foo, and it's going to get expanded. I guess let's just do foo 10 to something 10 foo. So what's the algorithm here? So first of all, we know, because I think we decided in an earlier episode, and it's still a good pattern, whenever you run put, we need to have a function called resolver or expander, I guess, or referencer. It's basically our execution engine, because get and put, I mean, they are execution, but well, there's no reference. I wonder if it's just going to do the references, because we also need to do the conditionals. It's a bit like a call. It's like a cell call, really, but within a context. So if we look at the cell call we already have, I'm not overwriting the function a few times until we get the shape done right, I mean. So cell call is definitely for something that comes from the outside. And then it just dispatches the get or the put, right? That's it. So if I write this cell it's I'm talking about the we make calls. It's called respond, expand. It's really what goes between call and response. It's the logic. But logic is a noun, it's not a verb. Okay, let's call it expand. It's a name that I really don't like. Resolve, respond. Okay, call and respond, but it's really not that. Or maybe it is, in a way. So, takes data space, get and put. No, it just takes get and put, really. So we're going to do a version with no reactions, let's say. So how is it going to be? I'm going to basically give me the entire data space, and then we're gonna I have something with scene. I need that. Actually, I don't need the scene. I can just do it with a get. So it would be something like So we basically stop not. We're going to stop when we find a change and call ourselves recursively. Because if something changes, then we're going to rerun the whole thing until nothing changes. That's going to be the brute force approach for now. Then we'll replace it with a list of dependencies. So let's just write that down. Brute force version cell.respond brute force one actual change and recompute if there's a change. Capo al fine, just go back to the top. Just the capo, no, because it's not al fine, because you keep on restarting. You go through the space, you stop on not undefined. I guess it's stop on true. Path. So if path index of at equals -1, then return. We can do like current value. It would be at this. Wait, index of is the rightmost, right? No, the leftmost. I don't know. Last, if I do this, I get undefined, right? Yeah. P equals at return k. So if at so we remove, and then we slice it, then we get the current value will be get yeah, so get query path context path get. The query path will be path, context path is nothing, the get is this getting function. The current value will be the path with an equal. It will be previous, I guess. Current value will be cell get you get whatever is there. And I guess we should allow dots, right? Yeah, we should allow dots. That's a good one. So you will get, I cannot destroy information here. Our query path. I took the current value and now I do what? No. I need to get the path slice from k or k plus 1, I can't remember. And then the context path would be the context path. That's nice, huh? All right, I like how it's shaped there. Okay, this is good. We have the current value, and then we do, they're all sorted, right? Yeah, they have to be sorted. If they're equal, return. Otherwise, we are gonna do put. Oops. I need to write in Cyrillic. Paths, context path. Yeah, all this stuff. Oh, this is annoying. Oh no, it's not so annoying. It's fine. I just need to do something like current value I will do p. The path is, I guess I can just do absolute, right? Do I need to do absolute? Yeah, I can do absolute here. Actually, I think I have to do an absolute path. I will do query path concat. Oops, definitely not what I want to do. Yeah, that one. That's good. Yes, so I have that. The context path is nothing, well, empty. Get, put, and I'm not going to update the dialog, so that can go away. Return true to say, hey, there was a change. If change, not chance, change, cell respond. Look at this. I need to return, and never mind. Disregard. Yeah, the test run because I have not run this function at all, but let's just have some fun. Because I want to do direct and indirect references. Why am I always ahead of myself? I don't get it. I do footer and that's it. And then I set reffoo is add foo. Actually, this won't work. I need to do with put. I want one of these. It goes with the if this works, it's gonna be beautiful. And I don't mean in terms of the code. I mean conceptually. If this edifies with the ads, it actually makes sense. It's easily the best thing I've done, well, intellectually in my entire life. Let's see. That's the bar. No pressure. So I put this. So what I need to do now is I need to call cell.respond. That's it. Looks so innocent. I guess the moment to do, sorry, not there, here the put. If there's no changes, it will be done. With the puts, there's no recurse because it won't put stuff unless it has to change. Then there's no. So here I'm just gonna do cell respond. Ah, no, because I had to do it on the actual data space. I wonder if I should validate again here. Yeah, okay. Yes, we should validate, I guess, with the circular references and whatnot, but let's crash against that wall before we... it's not K, it's add, right? Yes, of course. And if add is undefined, because it may well be the first. Am I searching for add foo? No, I'm searching for foo. Yes, add plus one. The context path is indeed the query path, right? Yeah. No, yeah. Okay. Now, if I get everything, what do I get? Moment of truth. Okay. Yeah. Oh my, I completely forgot the values. Whoops, sorry. Yes, of course. What was I thinking? So this beauty, I'm not using the spread operator because I want to make this run in Internet Explorer 6. Yeah, It had to be set, and I set it. What am I doing? Okay, now. Okay, now. No. Wow. P. P is reffoo. Yeah, that's correct. And value is add foo. Why is it not being called? Yeah. What am I expecting? So I want this reffoo, add foo. Why is there a P there? It's annoying. It's just not sliced. This is so. Wait. Yeah. The path is reffoo. And the context, what is it? Empty. I think the issue size should be no. Wait. Why is there an at? Yeah, I think I'm making that's the put. We start here. Few more lines. I will do paths to put. put, that's to put. Okay, why is it not working? It's setting p reffoo, yeah, to value of 10. Why is it setting to 10? Ah, yeah, because it's the it's funny. It's like the easiest part is failing, and I cannot figure out why. No, it's not failing. It's actually no, yeah, because there should be no p here. Because I'm calling put instead of okay, now that was so stupid. All right, it's good, it worked. Okay, one more test, and then we'll call it a night. Earlier than I wanted to, but I let life get in the way. This is good, huh? I have to say. This already is direct reference right there. I thought it was a good idea to put those spaces there. It doesn't matter because where we go, we don't need pretty printing. Oh, come on. What is it? Yeah. Commas. And if I said, oh, this is gonna be a good one. If I put foo to 20, oh, this is it. This is it. And if I do a get, all the 10s are 20s. It's alive. Oh god. These are the moments that make it all worth it. So now this is reference. This will work for any reference, I believe, because unless you do something dense as overwriting the results, which I don't think we will, like explicitly, and even then it will just rerun, so we always have the last word. Actually, that was a good test. I want to put p reffoo equals to 30, and I want to show that I will still get 20. Yes. That's beautiful. Even if you override the keys, they will be overwritten again by cell.respond. Oh, this is perfect. Okay, so next I think we have direct reference. To do for next time, indirect reference jump over equals and that really covers it, I believe. Do you have something about indirect? Episode 25 and 23. Yeah. We got this. It's really there. So it's really about this. Seems like in the old episodes, I remember all the to-do lists, and even once I do something else. Interesting pattern. Okay, this works. I think we're gonna stop now. Actually, maybe we can commit the changes. Yeah, let's remove those clogs. We will comment respond, but not today. Or not tonight. Look at that. Okay, I think we're done now. Thank you for watching.